In this video lesson, what we're going to do is take a look at finalizing the graphics for the game. So what does that mean? I mean, because right now we do have graphics, of course.
Right.
We can see our little guy running around. We can see little monsters running around, evil monkeys, that is. Finalizing graphics. Well, let's think about it. First of all, when we start the game right now, well, let me say this. When we start the application,
Right.
No game has been started. There's no instruction whatsoever for the user to go to File and New Game.
Basically, when we're at state null.
Right. So let's go ahead and start it out by telling the user inside the canvas area that we draw to that, hey, you need to click File, New Game to start a game. That's one thing. When a player dies and the game is over, let's give a message that says this is the end of the game.
Yep.
Plus, following this setup later on, we can come back and say you have won the game once we move over into the world of
Right.
packages.
Any information that we need to
Any
display.
kind of information. And then finally, and probably the most interesting thing about this lesson, let's go ahead and set it up so that if the user resizes the window, the game is going to proportionally resize. So we can
Right.
maximize it, or we can make it smaller, or whatever. And all of our tiles are going to scale appropriately.
Yep.
Right. Hey, you're stealing my words there.
Aha.
And it's going to look great. So that's what we're going to do. Joel, you want to talk a little bit about the objectives as we've got them broke down here?
Yeah. The first thing that we're going to do is create the prototypes for the necessary functions, as we've done before. The draw information is basically going to handle when it says go to File, New, game is over, etc. Stretch game view, we're going to be creating a new back buffer. So we're going to have two back buffers, a regular back buffer where everything's going to be drawn to at regular size. Then we're going to have a final back buffer where we're going to take the original back buffer, stretch it to fit the final back buffer, and then draw that to the actual screen.
So basically everything we see by the end of this video on the screen has gone through the
final back buffer.
The final back buffer.
Exactly.
Cool.
And flip back buffer is just going to print the final back buffer onto the screen. So it should be a fairly short function.
Okay.
From there, we also need to handle the size event, because when the user stretches out the window, right, we want to recreate the final back buffer so that it's the right size. So that's why we'll need to be handling the size event. Implementing the stretch game view, at that point we'll just implement what the prototypes that we created up above and handle the size event. And finally we'll just take a look at how to draw the information. And just as another note, right after 3 we will be able to test the game to see how it's working. And then afterwards, at the very end, we'll just kind of clean up by making it look a little bit more professional, put some information about what kind of state we're currently in.
Sounds great.
Alright, so let's go ahead and go to our evil monkeys and perform the first step. And that would be go to our header files, go to app frame, and let's go ahead and create the prototypes that we need. So right down here, let's add our first one, which will be the draw information. And we don't need to pass it anything, so just void. And let's do our stretch game view. And finally our flip back buffer. And of course we don't need to pass that guy anything either. And VO'd is not right, so let's change this to void.
And while we're in there, we can go ahead and
Do
back
the
up in the
OnSize
public, up in the public section, go ahead and create the OnSize prototype.
And it's going to be a size event. And one other thing we're going to need to do is create the new back buffer that I was talking about before.
Right.
Right down here you'll notice that I do have the wxBitmap back buffer.
So here comes another wxBitmap.
Yep. And this guy's going to be the final back buffer.
The final.
Oh yes. And remember, this guy is going to be created at the in the size events. So
Right.
that's very, very important to keep in mind. So now, the first thing we're going to do is go to the appframe.cpp and make sure we initialize this guy to null.
For sure. The
That's
final back
very,
buffer.
very important. So, yeah, the final back buffer. So we set that to null. And let's override the event so that we're handling him. So we'll use the size event, that is. So put this guy in here. And this is going to be wxEVT_size. And what event do we want to call? OnSize. Which member function, excuse me. So that's nice. Now what we're going to need to do is actually create the function. If we could just go back to context for a second. What we've just done has pretty much handled step number 1 and step number 2. And now comes the exciting thing we have to do, and that is implement these different functions.
Right.
And the first thing I'd like to do is actually create the OnSize event, because that's kind of the foundation for getting the back buffer, the final back buffer, all set up and ready to go. So let's kind of put this right before the onPaint function. And let's create our appFrame OnSize function. wxSize event. Alright, so in here, the first thing we're going to do is call event.skip. Now, what this basically is saying is we take the OnSize event. In the OnSize event, by default, a lot of things are going on. The wxWidgets is handling a lot of extra stuff. So basically, this is saying, do what you typically do, and then afterwards, we'll do what we want to do. Some extra functionality to this event handler.
Right.
So the first thing is, as we did in the other events, we're going to first clean up after ourselves, so delete it if it exists. So if there exists a back buffer, delete it. Get rid of the old one. And then we're going to get the client area of our game window. So we're going to say create a wxSize client area and do a game window and then
get client size.
Get client size, exactly. So this is going to return to us a width and a height of the current viewing size.
And with that, now we can go ahead and create our final back buffer.
Exactly. So we can say final back buffer, and it's being created exactly like we did with our other back buffer. So new wx bitmap, yada yada yada, client area dot get width,
and a client area dot get height.
Yep. So there we are.
And then finally, of course, we're going to need to call update view.
Yeah, so everything can be drawn. Otherwise, it would just
it'd be sitting out there in memory.
Yep.
Just in the final back buffer. Correct.
So we update the view here. Now, with that done, let me just switch back over to context for a second. So we've got this guy handled. Now we need to do the stretch game view and the flip back buffer. The stretch game view is very important, so let's go ahead and do that one first. So let's switch back over into our Evil Monkeys code.
Okay, make sure your fingers are warmed up here.
Yes, because this is going to be a lot of typing. So let's scroll all the way down to the bottom here, right before update view. And let's do a void viewed. What's with me in viewed?
I don't know, man.
So do our app frame, and this is going to be our stretch game view. Alright, now, this is going to be a hefty function, so everybody prepare yourselves. The first thing is we're going to get the client size again so that we can use that information when we need to. So game window.get client size. We're going to be using this quite a bit. We're also going to create another local variable called stretched size. Now, if you guys remember from the first video, when we stretched the window, everything was stretched proportionally. We don't want it to just be totally filling the screen because we would get this weird stretch shape.
Right.
So this wx stretch size will take whatever's in client area and calculate the width and the height we needed to have it stretch proportionally and fit inside the viewing area. So, first thing we're going to do is take client area and get its width and multiply it, and I'll explain this in just 1 second after I type it out. Get the level's height and divide it by level get width. And make sure that is less than the client area dot get height. Okay, so what is this if statement doing? Let me just kind of stretch this out a bit so you guys can see what's going on. So there we have it. This is basically a simple proportion. If I just open up Notepad for a second, this might help just a little bit. What I'm doing here is get the client area width. So we do know the width. So let's just say that's client width. And that's going to be divided by, or multiplied, excuse me, by the level width, or level height. Just kind of trying to get you guys to understand how this is working. And we're dividing that by the level width. And this is going to give us what? The client height, right? And we want to ensure that the client height that we're calculating right now isn't going to stretch beyond the game viewing area.
Right.
So this is simply a proportion. That's all there is to it. So if it is less than, then we're going to go ahead and store this into our stretch size. Is that making sense? So what we can do is a stretched size.set, and then we simply set an x and a y, and it's going to store the width and height inside of this guy here. So we're going to say client area dot get width, because we're using our proportion here to get the height. So the width is going to simply be the entire width. And the height is what we calculated above, which is this guy right here. I could have even stored that in a variable, and it would have probably made it easier for people to see. But so there we have it. So we stretch the size. Otherwise, if that doesn't work out, if it's going to be greater than the get height, what do we do? Exactly the opposite, in fact. So we stretched size.set, and it's going to be a proportion very similar to this, which is going to be
the client areas dot get height,
right,
times levels dot get width, and divide it by, and just level dot get width,
get height,
or get height. Yeah. Blah.
Yeah, it gets confusing after a while. So then, of course, in this case, well, let me not forget my little, because this is a function that we're calling here. And in this case, otherwise we want it to be client area dot get height.
Right.
So there we have it.
Very nice.
Now we have our stretch size. So with this information, we want to take the back buffer and stretch it to the correct size. So let's do a create an image, because the wxImage provides a member function for us to scale the image, which is awesome. So
we need to convert.
So yeah, let's create a stretched image, and let's convert the back buffer, which is, remember, a wx bitmap.
Right.
And let's convert it to an image, because a wx bitmap does not have a function for stretching.
Right.
Or at least not yet. So let's take the stretched image, and let's equate that to stretched image dot scale. So we've just taken this the back buffer, converted it to an image, put it into stretched image. Now we're going to scale it down to what? Well, stretch size dot get width, and, well, remember the function, and I can spell, really, dot get height.
And a comma in there too.
Thank you.
Mm-hmm.
Bink.
Bink, bink. Yeah.
And so now we have the stretched image inside of, well, stretched image. Makes a lot of sense. And now what we want to
we need to get that back over into a bitmap.
That's right. So we're going to take our wx bitmap, and we're going to create our final image. And this is going to be of size get width. Well, get width. Thank you very much. And client area dot get height. I'm getting kind of ahead of myself here, aren't I?
Not that bad.
Now, of course, we can't draw to this final image until we need to get a DC to it.
That's right.
So what we're going to do is say wx memory DC, the final DC, which is going to be the destination, and then another memory DC, and this is going to be our image DC. So for the final DC, we're going to select an object, which is our final back buffer, because that's where we want to put the final image, right?
Right.
So we have our final back buffer. And for our image, well, we want the stretched image now, don't we? So we'll say image DC dot select object, and then we want our, what do we want here? Our stretched image.
Our stretched image, yeah.
So let's just take stretched image. Okay, now, what else do we want to do? First thing, we want to kind of clear this guy out with a black background. So let's say final DC dot set background, and we'll set this to a black brush. And then, just so that it actually clears it to black, let's set it to that. Now, the stretched image is proportionally sized, but we want to make sure that the stretched image is centered onto the viewport, or onto the view, whatever you want to call it. So we're going to calculate this position. So we'll take wx point, and we'll call this center. And the x value is going to equal the client area dot get width. Don't forget these guys. Minus the stretched area, stretched size, yeah, dot get width, and divide that by 2. So that basically centers it up. And we'll do exactly the same thing, so let's copy this for the y as well. And except...
to get height now.
Yep, it's going to be get height.
Get height, and there you go.
So now we know the center. What's the final thing we need to do, Buzz?
Oh, copy the stretched image onto the final DC?
Yes, that sounds like a good plan to me. So we're going to take our final DC, and we're going to blit it onto the center. And let's see.
Here's our stretch size.
We're going to take stretched. Okay, I'm sorry here. The stretch size is what we're going to, the size of what we're going to blit onto it. Wow.
It's okay. You're doing great.
And then we have our image DC, which is the guy that we want centered up on it. So our image DC, and we're going to put it at 0, 0. Okay. let me kind of clarify. This is the destination position where we want to put the image. This is the size that we want to put the image onto. And this is the source of where we're going to get the image from. And then this is the destination where we're going to get it from. So it looks at 0, 0 inside of image DC, prints it right here at size, stretch size.
There you go. Very good.
Okay, so finally what we're going to do is draw a black border around it. So no worries here, just set the brush. So we're going to set the brush to transparent because we simply want outline. We don't want anything in the inside. So if we just set the brush to transparent, everything will be good. So we set this to WX transparent brush. And then we just draw a rectangle around the entire viewing area. So WX point, starting from the top left, which is 0, 0,
0,
and go to the bottom right, which would be stored in client area. Simple enough. So, let's see. With that, the last thing we need to do is remember, anytime we select an object, be sure to clear it. So, let's go ahead and do image DC dot select object wx null bitmap.
Since we have 2 of these, could you imagine how nasty it'd be leaving both?
Oh yes, especially since this is going to be called every single time we resize our thing.
Right.
It gets very, very nasty. I mean, you can run out of memory in no time at all. And I actually, final image, I'm not really using this. I don't know why I created this here, so let me just delete that out.
Okay.
I wasn't really thinking very clearly, apparently. But otherwise, this function is created.
Cool.
We've taken our original image, our back buffer, stretched it, and blitted it onto our final DC, which is our final back buffer. So with that created, I know there's a lot there. If you kind of didn't get exactly what was going on.
Beautiful rewind button is
yes,
not far away.
It's a beautiful thing. So now, just so that we can actually see what's on the final back buffer, we're going to
flip
need
back buffer functional.
Yes, exactly. You stole my words.
I am sorry.
No, you're not.
Okay.
So inside of here, we're going to again get
the client area.
Yeah. So we have our WX size client area, and that's going to equal the game windows get client size. Click client size.
Let's get a WX memory DC.
Somewhere to put it to. So our final DC. And we're going to need a client DC as well, which is going to be our final where we're going to see it, right?
Right.
So we have our what I call the screen DC. And remember, that's going to be our game window. And then we're going to select the object. So final DC dot select object. Our final back buffer. Final back buffer. Thank you. And then all we need to do is blit this guy back on. So screen DC dot blit WX point from 0, 0. That's where we want to print it to. Because remember, the final back buffer should be at this point exactly the same size as game window.
Right.
So all we need to do is print it to the top left corner. It's going to be of size client area. And we want to get it from final DC, which is the final back buffer. And the source DC is going to also, well, the source position is also going to be 0, 0. So there we have it. Only one.
Except don't forget.
Yes, do not forget. Once you select the object, always unselect it, if you will.
That's right.
There should be an unselect object, but you know. wx null bitmap.
All right, I feel better.
Yes, me too. So at this point, we pretty much just need to change the update view so that we have, well, so that it actually calls the stretch view and updates it properly.
Right.
Am I correct?
Mm-hmm.
So just give me 1 second so I can look through my notes here. So many notes.
And to be honest with you, Joel, I don't think you actually printed out notes on that one. Or did you?
Yeah, I have it right up here.
Look at that. I am so impressed.
Yes, you should be.
Okay.
Anyway, so right here, what we're going to do is, if the game state is equal to game in progress, what do we need to do? Well, in this case, that means the back buffer definitely exists, right? Because we've drawn it onto it. And what we're going to do is say, stretch game view. Simple enough. But for both cases, when we end up implementing our draw information, they both going to need to flip the back buffer. So simply like that. Now, if we come back to context, just so you guys can sit back and look at exactly what we've done, we've just implemented the stretch game view, we've implemented flip back buffer, and we have handled the size event. So the only thing left to do is do the draw information, but that's something extra. So at
we
this
should
point,
be able to test this out.
Yes, we should be able to test this out. And since everybody is calling update view, we don't need to change any other references to it, and it should all work fine.
Right.
So let's see if I made any errors. Flip back buffer is not a function. Actually, I meant to have a lowercase b right there. Okay, final back buffer is not a member of. Well, let's just go back to here and let's see how I named it up here. Dun, dun. Oh, I named the function final back buffer. Don't know what I was thinking there. So let's recompile this. Oh man, only one typo. That's not bad.
Not bad at all.
So let's make sure this works. So right now you won't see any difference, but when we go to File, New, check it out. When we stretch this guy out, okay, we just went to Game Over. So
right.
Look at that. It's automatically stretching it so that it fits proportionally onto the screen. So everything's working great.
So quick maximize?
So if we maximize this guy, check it out.
Aww.
Isn't that special?
Yeah.
So the last thing we want to do is make sure that when we end up dying, or let me kill this guy so it's easier to die.
When we end up dying?
Thank you for that. When we end up dying, right now we are at state game over, right? But we don't see that. We see, well, it's just kind of frozen. That's not cool. So let's go ahead and exit this out and implement our final function, which is going to be our draw game information.
Draw information.
Draw information. So let's come down to here and do our void app frame draw information. And we'll pass it a void here. And again, we're going to get our client size, and I'm getting really tired of writing that.
There you go.
And we're going to create another memory DC, and we'll just call this the back DC, or final DC, just to make it a little bit more the same as what we've been doing up till now. So final DC, we're going to select the object. And again, since our update view is always flipping the back buffer, that's where inside the draw information we're going to be drawing to. So we have our final back buffer. And let's just clear the DC out. So final DC.clear. And we're going to draw a black rectangle around it. So all we need to do is do final DC.draw rectangle. And starting from the top left, and we're going to go to client area dot get width, and let's see, client area dot get width and client area dot get height. Very simple.
Okay.
Now's where the actual thing begins. Depending on which state we're in, we're going to be displaying a different message, right? So let's go ahead and create a series of if statements that decides what message we want to print. So let's create a local variable called message, and we'll say if the game state is equal to state null, set the message equal to go, let's say go to file new to start a new game. So the people know, okay, I've just started the game, might as well go and do something.
Right.
Otherwise, else if game state is equal to state player 1, which in this case we can't win the game yet,
yeah,
right?
It's not there.
But let's just go ahead and implement it for this case, and say message equals you have won the game. So some hypothetical situation. And finally, if game state is equal to state game over, go ahead and say message. You can say game over, you suck, but we'll just say game over. So there we have it. Now we have which message we want to print depending on our game state.
Right.
So let's go ahead and print this. But first we want to calculate, we want to center this on the screen, right?
Right.
So again, we're going to use a calculation much like we did a second ago when we calculated the center. We'll have a wx point center. But to calculate this center, we're going to need the actual width and height of our text, right? And what's really cool is, again, wxWidgets comes to our rescue and tells us we can get the width and height of a specified string. So let's create a text width local variable and a text height. And using the final DC, there is a function called getTextExtent, which basically returns information about a certain text. And the first argument that we need to pass is message, which string we want to test, and then we'll pass it a pointer to our text width and our text height. So after calling this getTextExtent function, text width and text height will contain the width and height of whatever's inside message.
Right.
So to now calculate center, we can just use the constructor for our wx point, and we'll do what we did before. We'll do client area dot get width, and then we're going to minus that by our text width and just divide by 2. So divided by 2. And then do exactly the same thing, so let's, except with height. So text height. And get height. Don't forget your 2 little parentheses, because I seem to forget a lot. So there.
Okay.
Now we have the center. All we need to do is draw the text. So final DC dot draw text. What text do we want to draw? We want to draw a message. Where do we want to draw it? At center. And of course, now that we're done, do not forget to reselect the object with no. So final DC dot select object wx no bitmap. So with that done, the only other thing we need to do is make sure that in the update view we actually call draw information, which means when it's at whatever state, it's going to draw the information. When it's not in progress, else draw what did I call them? Sorry, draw information. So everything should be now working properly. So the only other thing that we may want to do is just make sure that final back buffer is in existence before we do this. So let's call if final back buffer exists, draw the information. Let's compile that and hope that everything works properly. So it compiled okay. Let's go ahead and run this. Check it out. It now says go to file new to start a new game. And just let me go back to the code for a second here. Just go back up. You'll notice that that's because game state is equal to state null. It put that message in here and it's printing it out. So if I go to file new, and let me die because that's really the only other information that we can see. Think it switches over to game state null. I mean game state over. And check it out. It says game over.
Very nice. And the data on the right-hand side, of course, is still up to date.
Yep.
All 3 enemies exist. You're still on level 1, but you're dead.
Oh yeah.
And with that, that's really going to wrap up this lesson. We've achieved what we set out to do.
Yes, we did.
Putting out some information. We finalized the graphics information, and we can now resize the screen. Hooray!
Yay.
Okay, so with that, it's going to wrap up this lesson. Thanks, everyone.